Hello, my name is Dustin Keys, and I'm a graduate student at the Oregon State University Seafood Lab in Astoria, Oregon. Today I'm going to give a short lecture on Clearwater recirculating aquaculture systems. Clearwater recirculating aquaculture systems are perhaps the most intensive systems in aquaculture, requiring many artificial inputs and managing the outputs effectively. Since Clearwater systems allow the aquaculturist to control a wide variety of inputs, an array of species may be successfully grown. Some of the better-known species that have been successfully cultivated include shrimp, cod, sturgeon, trout, and all sorts of groundfish. The carrying capacity varies with the type of system used, but Clearwater recirculating aquaculture systems generally have the ability for the highest fish densities. Arctic char, for example, may be successful at densities greater than 100 kilograms per meter cubed, and tilapia may be grown at 60 to 70 kilograms per meter cubed. That is, if there's plenty of aeration and the wastes are managed effectively. The density will depend on the species, but these generally higher stocking densities allow Clearwater recirculating aquaculture systems to be an economically viable choice. In this figure from the AKVA group, you can see the complexity that these systems can reach. You can see up there at the top that software is used to control many aspects of the system, including how much the fish get fed. I'm sure their system includes water quality management and things like temperature and dissolved oxygen considerations. And you can see here below the tanks in this long part that, number one, it's modular. You can see you can take out, let's say, the mechanical filter and put one in because it's different than you can see where the pumps are or where the biofilter is. And you can see that there's a mechanical filter, UV filter, carbon dioxide stripper, oxygen control, pumps, a biofilter. We're going to go through these one by one. If you go to aquagroup.com, you can see this example and more creations that they have. So Clearwater systems are perhaps the most challenging to discuss because there's no clear right answer. Each system is slightly different from the others depending on the species cultured, company preferences, design limitations, and cost limitations. We already know that we need tanks to grow fish, of course. The water will need to recirculate at an appropriate rate. The water will need to be filtered somehow, etc. But I'd like to focus on the recirculation process in particular. The recirculation process is one of the areas in the system that can be diverse, and the health of your fish will depend on the success of your recirculation and filtration processes. One of the filters that may be included in the recirculation process is a mechanical filter. A mechanical filter physically separates solids from water. This type of filter will typically remove particles down to 50 microns. There are several different categories of mechanical filters, including drum, cartridge, sand, and bag, but the drum filter is the most popular. You can see here in the picture an example of a drum filter, and what's happening is you're getting an inflow, and then the drum is spinning around and around, and the water is going to go through the drum. As you can see there, the water filters through the screen, and then the particulates will stick to the screen. They're going to get scraped off as the drum goes around, and then you can see there's a little discharge pipe coming back out. But the bulk of the water will, as you can see on the right-hand side, outflow to the tank. So another filter that you're going to need is a microfilter, which should be after the mechanical filter, because the microfilter removes suspended particulates that are less than 50 microns in diameter. Now, if you put your microfilter first, what's going to happen is the larger particulates are going to block the pores, and you're going to get pressure backflow. Once again, microfilters are going to be cartridges, bags, or very fine mesh screens, but I believe the most popular is a cartridge filter. You can see here on the right that that's a cartridge filter, and you can see the inflow and outlet, and on the inside will be the cartridge. And you can see there at the top that there's a pressure gauge. You will need to monitor pressure carefully because as particulates stick to this very fine mesh in the cartridge, what that's going to do is it's going to block the pores, and the more pores that are blocked, the higher the pressure is going to go. So you will need to take the cartridge out and clean the cartridge off or replace the cartridge with a new one to keep the pressure at manageable levels. It's important to include these filters because particles that they remove are particles that will remain suspended in the water instead of sedimenting to the bottom of the tank, like the particles that are removed in the macro mechanical filtration. These suspended particles may be particularly hazardous to fish health. A UV filter may be used to control bacteria and smaller parasites. This filter is basically just blasting the water with ultraviolet light. Now, ultraviolet light is radiation, and if you're blasting the water with this ultraviolet light, you're basically subjecting the water to intense radiation. Now, the filters are not going to remove all bacteria, and it won't remove viruses, and so this intense radiation will help break down any bacterial and viral nucleic acids that are present. There will be irreversible DNA damage to these bacteria and viruses, and they will die. Ozone can also be used instead of a UV filter because you can get away with lower daily water exchange rates, and oxygen is produced as an end product. The half-life of dissolved ozone is only 0 to 15 seconds, but it is poisonous to fish. So you do need to make sure that the water continues through the system for a few minutes before being pumped back into the tank. You don't want to put your ozonator right in front of the outflow, for example, because then ozone will kill your fish. If you want to know more about ozonation and UV disinfection, then you can check out this link at the bottom of your screen, and it's a PowerPoint from the University of Arizona. Also, you can just type in ozonation University of Arizona, and it'll bring up, I think, it should be the first web page at the top, should be this web page in your web browser. A biofilter may also be added to Clearwater recirculating aquaculture systems. I just want to quickly say that a biofilter is a matrix. A lot of times it's a plastic matrix, and has this plastic or other media has a high surface area. What the high surface area does is it allows a lot of nitrobacter and nitrosomonas to grow that will help modify harmful ammonia and nitrite into less harmful forms of nitrogen like nitrate. This is an aerobic reaction, so it's going to use oxygen, which is an important consideration when designing the system. For the most intense systems where water is recycled quickly, biofilters will really not be that effective to utilize because the water is not going to spend enough time in the biofilter for the bacteria to do much good. But you can see here in not as high intense systems, in this figure on the right, at the top you have an inlet pipe, and then the water goes down the media, and the bacteria are on this media, and then the outlet pipe is at the bottom. And in this biofilter, they've included an air stone to actually help include oxygen into the media. And the last thing I'm going to talk about with regard to the recirculation process is oxygen addition as well as carbon dioxide reduction. You can bubble in oxygen during the recirculation process to increase the dissolved oxygen concentration, but if you do it this way, the dissolved oxygen concentration will be dependent on the pressure and pipe length of your system. Oxygen can be bubbled directly into the tanks with the fish, but this will definitely not be sufficient at higher stocking densities. For higher stocking densities, you can buy an oxygenator that produces 90% oxygen and is integrated directly into the recirculation system, or you can actually, in some cases, buy liquid oxygen that's also at 90% that can be added. Now you do need to know that if you're adding in 90% pure oxygen, once again, as we've seen in the ozonator example, you don't want to put it right before the water goes back into the tank. If you remember from the ACVA example, they were actually bubbling oxygen in before it was even filtered. 90% oxygen will be poisonous to your fish, and so you do need time to allow that oxygen to be mixed into the solution and have a lower dissolved oxygen concentration. You can see here in this figure that you have a flow coming in, and then it's going through these channels and then coming out the bottom, and you can see an oxygen feed gas is being bubbled in to the water, and excess gas is coming out of the off-gas vent. So carbon dioxide may be removed by some species of bacteria, but these species are likely not going to be included in your biofilter. Instead, you're going to have Nitrobacter and Nitrosomonas, which are going to actually produce carbon dioxide. So what you're going to need is a carbon dioxide stripper. And a carbon dioxide stripper will help remove carbon dioxide and sulfides as well out of your system. I should mention here, now that we've gone through everything to the carbon dioxide stripper, that an engineer will need to be consulted, if not hired outright, to help you design the system, because it is very complex. Once again, there's a short course from the University of Arizona if you're interested in carbon dioxide stripping. Just type in carbon dioxide stripping, University of Arizona, in your web browser, and it should pop up. It's actually a PDF. Now that we've seen all the parts of these systems, it's important to note that they need to be put in the right order. We have to start with the larger particle size mechanical filter, then the smaller particle size filter. Hopefully by now this should be obvious why. Ozonation or UV filtration should follow to remove harmful bacteria and viruses. Once a majority of particulates are filtered out and the bacteria and viruses are killed off, then adding in other pieces to the puzzle depends on what you're attempting to accomplish. For example, if you do include a biofilter, it needs oxygen and produces carbon dioxide. So oxygen should be pumped into the water before going to the biofilter, and the carbon dioxide stripper would have to be placed after. If a biofilter is not used, then the carbon dioxide should be stripped from the water, followed by aeration, because water has a greater affinity for carbon dioxide. And you're going to get less of a DO concentration if you bubble in the water without removing carbon dioxide first. So I've split the system into all these different parts because once again they do exist as different parts and the system is modular. You can add in and take out what you want and just connect them with pipes. I'd also like to briefly mention that since this is a Clearwater system, you will need to feed your fish multiple times a day because there's no food in the water. The temperature will also need to be carefully controlled at all times, and a pump is required. Now you will need the proper pump for recirculation, and once again this is where you're probably going to have to consult an engineer because most people don't know off the top of their heads how to calculate the head that you're going to need for your system. The amount of head is literally just how high a pump could pump the head water, and this is going to depend on the complexity and the equipment in your system. And lastly, you do need a plan to handle all the waste that's going to be generated. There are many factors that go into the cost, gear durability, and maintenance of the system. And once again, this all depends on the type and quality of individual components that you buy. Costs will depend on the amount of capital you have at startup because larger systems often have lower maintenance costs than smaller systems based on cost of kilogram of product. If you have a lot of startup capital, and we're talking millions of dollars, then you can design a large facility that has a low cost per kilogram of product. Even if you and maybe one other employee are going to run a relatively small system, you're still looking at money in the hundreds of thousands of dollars range. It is important to note that these systems are definitely not cheap. When we discuss costs, there are specific considerations that need to be taken into account that are associated with the system's size. The larger system that you have, the more fish that could potentially be killed if a harmful disease is introduced or if the system goes down. Hopefully you would have backup generators and other redundant systems integrated into your recirculating aquaculture system in case like the electricity goes out. But the point here is that we can't always account for all the issues in the system, and these issues could have an impact on your fish survivability. The best we can do is just try to minimize the impact that an issue would have on your system. Now, if you have a huge system containing one gigantic tank and just one recirculating system, then disease could kill millions of dollars worth of product. If you have a large amount of initial capital, then it could be more advantageous and safe to build multiple different systems that are independent of each other. However, this would be much more expensive in initial equipment costs. So you can see that there's not one perfect option. And if you have a smaller system, then you're going to have to be really careful because you are just going to have one system. For this last slide, I just want to drive home the concept of money. We've been talking about money and how expensive these systems are, but it is important to note that money is the most important consideration really in any business, because if you don't make it, you're going to go out of business. Everything costs money, and even things that you don't think of will cost money. All of the equipment, the complex system of pipes and tanks, personnel, careful monitoring of water quality, fish, the fish themselves, the feed, and it's just a host of other things. Like pH. You're going to need chemicals to bring up or down the pH depending on the water quality, and so you have to buy those chemicals. So thank you for listening to my presentation on Clearwater recirculating aquaculture systems.